Assalamu alaikum everybody, hello. Today we will deal with a question. Do we have a relation between the convergence of a sequence, a real sequence, UN, suppose that UN converge to L? Actually, we have this implication for all subsequence, they converge to the same limit. So if UN converge to L, we have this relation U phi of n converge to for all phi of n. This is a change of variable, so this is an increasing function from n into n. This permits us to define, actually this is a definition of subsequences. So if UN converge to L, we have for all subsequences, they converge to the same limit. Do we have the inverse implication? Actually, we have the inverse implication in another sense, but under some hard conditions. This is one of these conditions. If we have UN converge to L, this implies that U to N converge to L and U to N plus 1 converge to L, because this is defined subsequences and this is an increasing function from N into N. So we have two subsequences and they converge to the same limit. In this sense, is it true? Actually, yes. Why? U to N converge to L. This is equivalent with for all epsilon greater than 0. We can find a rank such that starting from this rank, we have the difference between U to N and L is less than or equal to epsilon. And U to N plus 1 converged towards L. This is equivalent to say for all epsilon greater than 0. There exists a rank n2 of epsilon, such that for all n greater than or equal to n2 of epsilon, we have the difference between 2n plus 1 minus n. This is less than or equal to epsilon. So, let us take capital N of epsilon equal to the maximum between 2n1 of epsilon and 2n plus 1, so 2n2 epsilon plus 1. If we take an epsilon like this, then what we have? We have un converge to n. Why? Because then we have for all epsilon greater than 0, there exists a rank n2 of n epsilon. This n epsilon is exactly this one. There exists n epsilon is exactly this one, such that for all n greater or equal to n of epsilon, this implies that the difference is less than or equal to epsilon. Why? Because when n is greater than n of epsilon, this means that is greater than the is equal to the maximum between both ranks. So if n is even, this condition ensures that n is greater or equal to n1 of epsilon. So this is true. And if n of epsilon is equal, and if it is odd, this means that n of epsilon is the maximum between these two natural numbers. So in both cases, we are sure that n is greater of both of them. Then even or odd, we will always have this inequality. I repeat once again, n can be even or odd. If it is even, so we apply this, and since n of epsilon is greater than the greatest between them, so we are sure that we 2n is greater than n1 of epsilon. Then if n is odd, so n take the form 2k plus 1. K belongs to n, and since n is greater than n of epsilon, this means that 2k plus 1 is greater of this. This means that k is greater than n2 of epsilon, which permits us to deduce that the difference between un and l is less than or equal to epsilon. And since this characterization is verified, this means that the limit of un is equal to n when n goes to plus infinity. As a conclusion, here we have to distinguish between odd index and even index. And in both cases, these two possible cases ensure that this is true. Can we extend this? Yeah, we can extend. What we can remark that natural number is the union of odd number union even. This is the secret. This is the secret. Suppose that we take u for n converged to n, u for n plus 1 converged to n, u for n plus 2 converged to n, and u for n plus 3 converged to n. If both of the fourth subsequences converge to n, this implies that un converges to n. Why? Because here at this level we will take for n plus 1, u for n plus 2, the same thing. So the main n3 of epsilon, such that here we have for n, and here for n plus n. The same story, u for n plus 2 minus n less than or epsilon, and u for n plus 3 converge to n. This is equivalent. The same story here, and u for n plus 3 minus n less than or equal to epsilon. In this case, there exists n of epsilon, which is the maximum between what? n1 of epsilon, we take for n1 of epsilon. n2 of epsilon, we take for n2 epsilon plus 1. And for n3 epsilon plus 2, for n4 epsilon plus 3. We take the maximum between them. So for any given n greater than n epsilon, he has no chance. He must be one of the three cases. So for each case, one of these fourth ensure that the difference is less than epsilon. The secret, the magic secret, the great secret is that n is equal to, this makes a partition. So for n, union for n plus 1, union for n plus 2, union for n plus 3, n belongs to n. This is the secret. Since we have, and we can show for sure, we can extend this for any given beautiful and kind partition. As an application to this idea, what we can say about a sequence which verifies these three properties. Suppose that we have here a sequence such that u to n converge to L1, u3n converge to L2, and to n plus 1 converge to L3. What we can say about L1, L2, and L3, and what we can say about the convergence of un. From this one, we can deduce u we times by 3, so 6n, which is a subsequence of this subsequence, and we are sure that it converges to L1. This one, we can deduce 6n by multiplying this by 2, which is a subsequence of u3n, but both of them are subsequences of, this is a subsequence of this and of this. u6n is a subsequence of u2n and u3n. This means that necessarily L1 is equal to L2. And for this, what we can say, we can take u with times by 3, so 6n plus 3. This is a subsequence of u2n plus 1, which converts necessarily to L3. And if we take this, this can be a subsequence of this one. Why? Because here we have 3 times to n plus 1, and this belongs to n. So this is also a subsequence of this one. This means that L3 is equal to L2. What we can deduce? We can deduce that this subsequence and this subsequence converge to the same limit. And as we proved previously, if u to n and u to n plus 1, since they construct a partition of n, so if u to n and u to n plus 1 converge to the same limit, then un converge to the same limit. So we can say that un converge and converge to the same limit. Actually, L1 is equal to L2 and equal to L3. Thank you very much. See you next time.